Hello friends, in this lecture we will learn about differentiation and integration. Differentiation and integration are the prerequisites for learning physics at higher level. Calculus is essential for solving problems which contain variables with continuous variation. In junior classes, while learning physics, you solve problems using very simple formula. Like for calculating velocity, you were given displacement and time. The displacement varied with time, not by any complicated variation, but linearly. So, you never had to worry how the displacement is varying with time. But now, you have to consider the exact variation of one quantity with respect to another. That is the only reason why we are considering the course of calculus. Now let's get into the brief discussion of differentiation. First of all, let us understand what is a function. We are not going to the exact details of what is a function and what is not a function. That is the part of mathematics. We are just telling how does a function looks like. Let's say this is the independent axis x and this is the dependent axis y. There is a function that is y is equal to f of x. Here within the bracket we are writing the independent variable and the dependent variable is written outside. And f of x, that means as x varies there will be some variation in y. Now let's suppose that the curve that y varies with respect to x as such. Therefore, with respect as x varies, y also varies. Now, let's consider 2 points on this x-axis. This is, let's say, x1 and this is, let's say, x2. Now the corresponding points on the y-axis are f of x1, since y is equal to fx. Now let's substitute x1 in place of x, so f of x1, and here it is f of x2. Now let's define a quantity, that is delta y by delta x. Delta y by delta x means change in y. Similarly, delta x means change in x. And this whole quantity delta y by delta x means rate of change of y with respect to x. This means as our x changes, at what rate the y will change. Like if the curve was something like this, then the y would have changed more. Let's see at this point. At this point, for a little bit change in x, the change in y is not much. But at this point, for some change in x, the change in y is greater than at this interval. So, this is different for different parts of this graph. So, we can write delta y by delta x is equal to delta y means change in y. This is f of x2 minus f of x1, and here it is x2 minus x1. Now these are the 2 points. if we join them with the help of a straight line, can we say that this is the slope of the straight line? So delta y by delta x is actually the slope, because if this is theta, this is delta y, this is delta x. Delta y by delta x is nothing but the tan theta, tangent of the angle that this line is making with the x-axis. Okay. So this is a gross change from x1 to x2. That is the net change. Now, my question is, if I want to find the change, the instantaneous change at a point, what would have been my approach? Let's take a new page. Let's draw the same graph. It's almost the same. Y is equal to fx and here it is x. The point I am emphasizing here is, this is point A and this is point B. What if I could bring this point A and B very close, so close that they virtually represents the same point? Okay, let's do it. I am considering a point that is x, or let's say x naught. This is f of x naught, since y is equal to fx. This is A. Now I am considering another point that is B, which is very close to the point A, which is very close, almost on the vicinity of point A, almost lying on the point A but separated. This is x naught plus some h. So this will be f of x naught plus h. The distance between these 2 points on the x-axis is h. And to make sure that these 2 points are very close to each other, we'll state that h tends to 0. That is, h is a very small number which is tending to 0. Say 0.000001. And by making these 2 points very close to each other, we ensure that the straight line which we are drawing and this curve, these 2 coincides. Because if we draw a curve and if we consider a very small portion of it, say it appears to be a straight line. Exactly that concept we are using here. So what will be delta y by delta x here? Delta y by delta x will be f of x naught plus h minus f of x naught divided by x naught plus h minus x naught, which will be f of x naught plus h minus f of x naught divided by h. This is for any x and x naught and x naught plus h, but here h tends to 0 because these 2 points are very close to each other. So this is a special case that will be limit h tends to 0 f of x naught plus h minus f of x naught divided by h. That is dy by dx. For a gross change, we used to write del y by del x. But for instantaneous change, that means just from point A, we are moving to just the next point, point B. That means in the actual curve, this will be somewhat like this, A and B, or say the same point, that is P. So dy dx, say at x is equal to x naught. At this point, x is equal to x naught. These two are very close to each other, so we'll consider them as same point, just for consideration. So this will be limit h tends to 0, f of x naught plus h minus f of x naught by h. This is called differentiation from first principle. Now, this is the basic concept of differentiation. Also, we can say dy dx is equal to tan theta. Tan theta is, suppose say we have a curve and we have, and let us draw a curve. This is y, this is x. We are finding the derivative, let's say, at a point P. This is P is, let's say, x naught. This derivative will be something like this. It will be the tangent, because there will be 2 points. It is touching both the points. So this will be a tangent. And the angle made by the tangent is theta with respect to the x-axis. So we can say dy dx is equal to tan theta. So it gives the tangent and the slope of the tangent at that particular point. Now next concept let's discuss. We have a curve like this. Let's consider various points. Like let's consider this point as point A, this point as point B, this point as point C, and this point as point D. Now we have to determine sign. Sign is positive or negative. Sign of derivative at A, B, C and D. Let's see at the point A. At point A, let's see the nature of the curve. Just see the point, just see the curve just before A at this point, and just see the point just after A. The value of the curve is definitely increasing. The value of y is definitely increasing. So even if we draw a tangent at this point, the slope of the tangent is positive because the angle is acute. So we can say dy dx at A is positive. Let's see at point B. At point B, there is a maxima. That means this is the maximum value of the curve. Now, just before point B, the curve has some y has some value, and just after point B, the value remains same. And if we draw the tangent here, it is parallel to the x-axis. So we can say that dy by dx at B is equal to 0. Let's see here at point C. Just before point C, here we have y has certain value, but just after point C that value decreases. So as x increases, y decreases. So we can conclude that dy by dx at point C is negative. Now let's consider about point D. At D we have a minima. That means it is going to up to a minimum point, and again it is increasing. Just before point D, y has some value, and just after point D, if we check carefully, the value remains the same. And if we draw a tangent at point D, the tangent is parallel to the x-axis. So here also our derivative is 0, because tan theta is 0 here, and dy dx is equal to tan theta. So we have determined the sign of the derivative at A, B, C and D. So differentiation has many formulae. Let me list down some of the formulae. Like if y is equal to x to the power n, dy dx is equal to n into x to the power n minus 1. This formula can be derived using the principle of limits from the first principle of differentiation. Let's see another example. Y is equal to sine of x. Dy dx is equal to cos of x. Y is equal to ln of x. ln means log base e. Dy dx is equal to 1 by x. Y is equal to e to the power x. Dy by dx is equal to e to the power x. There is no change for e to the power x. There is another important concept from differentiation, that is maxima and minima. As we observe from this example, when the curve is reaching up to a maximum point, and again its value is decreasing, there will be one point at which the tangent will be parallel to the x-axis. We can have the same analysis for minima when the function is decreasing, and after a certain extreme minimum point, it will again start increasing, and the tangent will be parallel to the x-axis. In both cases, we will have dy by dx is equal to 0. But we have to consider one thing. The slope. Here the slope is constantly decreasing. Here the slope is having some positive acute value, then it is becoming 0, then it is becoming negative. That means dy by dx itself is decreasing. Therefore, dy d2y by dx, that is a double differentiation. We are differentiating dy by dx again with respect to x. That is less than 0 for the maxima. And here what is happening? Here we are having a negative slope, then 0, then positive. Here the angle is acute and here the angle is obtuse. So negative to 0 to positive. So dy dx is itself increasing. This whole dy dx. So d2y by dx2, that is the double derivative of y with respect to x, or derivative of dy by dx with respect to x, that is positive here. We will deal with maxima and minima in a separate chapter, but there are other terms also like global maxima, global minima, local maxima, local minima. We will deal that in a separate lecture. So we understand that for maxima or minima, or say rather for extrema, for extremum points, we get derivative is equal to 0 because the tangent is parallel to the x-axis. I hope this is clear for everybody. So now let us learn about integration. Integration is nothing but summation. Suppose we have given you, say, 4 dots. So you count the dots 1, 2, 3, 4, because these are discrete. So you can simply count 1 plus 2, 1 plus 1 plus 1 plus 1. Integration is summation in continuous variation. Now let's understand this with an example. Suppose this is number of students, and here I have given marks secured. For keeping this simple and short, I am just considering the students have secured. Let's make it grade secured. Let's say grade E, D, C, B and A. A is the highest, B is the lowest. Only one student has secured E grade. 3 students have secured D grade. 5 students have secured C grade. B grade has been secured by 4 students and A grade has been secured by 1 student. So if I ask you to calculate the total number of students, can you calculate? It's very easy. E grade has been secured by 1 student, D by 3, C by 4, C by 5, B by 4 and A by 1. So 3 plus 1, 4 plus 5, 9 plus 4, 13 plus 1, 14. Total number of students is 14. So this is very easy as it was discrete. Now let me give you another variation. Here, let's consider this is, say, temperature, and let's say month. I am considering that variation of temperature between January to April. That means basically from winter to summer. January, February, March, April. In January, let's say the average temperature daily was 15 degrees Celsius, and in April the temperature is slowly increasing in February, and it is again increasing in March, and finally increased in April. In April it is 35 degrees Celsius. In March it is, say, 30 degrees Celsius, and in February it is 22 degrees Celsius. In these kind of variations, where the temperature is varying daily, or the variation or the interval of variation is very small, we cannot add up just like this. Let me give another example. Here I am plotting the income of a businessman and days. Let's make it months. Let's say this is January, this is February, this is March, this is April, this is May. Now, the income of a businessman varies with respect to the profit he is earning from the business, and that is not constant. That depends on the various factors like the market, the customers, the conditions, etc. Let's say the variation is something like this. It was going well until March. Then April there is a sudden downfall due to lockdown, and again it is recovering at May. If I ask you to calculate the total income of the businessman, can you calculate just like that? It is very difficult, because if I give you the data, like in January his earning was something, in February his earning was something, in March his earning was something, in April it came down, still you cannot calculate the total income, because you have to get all the data in between also. From January to February you have to get the data in between, 15th January, 20th January. From February to March you have to get the data in between, like 15th February, 18th February. April you have to get the data in between, because if I give you the data of May and April, the middle part, this increasing curve, you cannot account for. So what you have to do is that you have to find the total income by integration. That means you have to find the total area. I will explain how. So this is how where integration comes into play. For discrete quantities we can just add up, but for integration, see, there is nothing between E and D. This is discrete. There is no grade which is having the value between E and D. But here, between January to February, we have 30 days, or every hour between the days, or every second. So it's a continuous domain. For discrete domain, summation is good enough. But for continuous domain, we have to perform integration. Now, let's see. We have y is equal to fx and an independent variable x, and the variation is somewhat like this. Now we have an initial point that is x1 and the final point that is x2. what if I tell you to find the area under this curve? How will you do it? What we can do is that we can divide this into, say, various rectangles. Now let's say this interval is delta x for every rectangle. Now if we add all the rectangles, then we'll get the area. But no, we will not get this portion. This portion will be left out. This portion will also be left out. So all these portions which is outside of the curve and the rectangle will be left out. Now what can we do to minimize this error? That is the calculated. We can find out this in this, and we can just calculate the sum of the rectangles. But what can we do to minimize this error? One way is that we can take smaller rectangles. So if we take smaller rectangles, this left out area we can neglect. Like if we decrease the interval, then it becomes only this much, the left out area. Now the point I want to emphasize is that let's take such an interval that is so small that it tends to 0. What I want to say is that this is x1 and this is x2. Y is equal to fx and this is x. Let's take such an interval that this length will be almost tending to 0, so that these left out portions, that will also tend to 0. Those portions will tend to 0 if we take this length very small, infinitesimally small. So we can take this as dx, as we have discussed in the earlier lecture, that dx means delta x tending to 0. That means it's a calculus notation. So since this is tending to 0, we can assume these 2 points are at almost similar level. So I can assume it at, let's say, fx. Now I can say this is a rectangle, because these 2 points I will assume them to be at the same level, because this length is very small, and we can consider these 2 points as the same point. So what if I calculate the area of this rectangle? The area of this rectangle, I can say it as dA. dA will be, this length is fx, and this interval is dx. Now, one such area is dA. If we, let's say this is x, at a point x we are getting fx. Now, if we can change x, if we increase x from x1 to x2, then this will be covered. Like if we take, for example, what I am going to say is that for x is equal to, we are changing x like this. Now as we increase x, we'll get the triangle here. Now we are traversing x from x1 to x2. So this rectangle will change from x1 to x2, and this rectangle will traverse the entire curve within our limits, and we can actually get the area if we can add these rectangles, small infinitesimal rectangles. So for the total area, what will we do is that we will integrate dA. What is integration? Integration is nothing but the sum. Integration is nothing but the sum, the addition. In discrete domain we add sum as like this, but in case of integration we use this symbol. That will be integration of fx dx. X is equal to x1 to x is equal to x2. This is nothing but the integration. It will give you the area under this curve. I will be giving you the formula to calculate the integration, but this is the concept behind it. The concept is important to appreciate the significance of integration. Now let us consider some formulae by which we can solve integration. Integration is almost, in integration we can say that is the opposite of differentiation as far as the formulae are concerned. Like y is equal to x to the power n, integration of x to the power n dx, that will be x to the power n plus 1 by n plus 1 plus c. In differentiation it was happening like x to the power n will be n into x to the power n minus 1. So it is opposite. N plus 1 divided by n plus 1. If we differentiate this one, it will become x to the power n. Then what is this c? This c, I can call it as constant of integration. This is coming because this is an indefinite integration, and for any value of c, whatever the value of c may be, if we differentiate it, it will become y is equal to x to the power n. For example, we have y is equal to x to the power n plus 1 divided by n plus 1 plus c. dy dx will be, we can take out 1 by n plus 1 because it's a constant associated with x. X to the power n plus 1, that will be n into x to the power n minus 1, n plus 1 minus 1, plus ddx of c. ddx of c will be 0. Why? Because it's a constant, and the value of constant is same, and it doesn't depend on the value of x, so this will be 0. So we can cancel out n plus 1 and n plus 1, so it will be x to the power n. So whatever be the value of c, that is 1, 2, 3 or 4, whatever, it will give the same value. Similarly, we have listed out the other formulae, and the rest of the integration formulae you can find it in any standard book, or I will be preparing it later. Now let me show you an example how to solve definite integral. Integration of x square dx from x is equal to 1 to x is equal to 2. How to solve this? First of all, x square integration will be x to the power 2 plus 1 divided by 2 plus 1. Since it is definite integral, it is having some limits, we may not give c because c will cancel out. I am showing you how. Let me give here a c. Now, since it is integrated within the limits x is equal to 1 to x is equal to 2, we'll put a square bracket here and write 1 to 2. This is x cubed by 3 plus c. At first we'll put here the upper limit, that is 2 to the power 2 plus 1 by 2 plus 1 plus c minus upper limit minus lower limit 1 to the power 2 plus 1 by 2 plus 1 plus c. As I was saying, this plus c and plus c will cancel out, so we don't need to put this constant of integration in indefinite integration. This will become 2 cubed by 3 minus 1 by 3, that is 7 by 3. So that's all for today. We have covered differentiation and integration, and this is very important for solving the problems of physics. So if you like my content, please subscribe to my channel and please comment below how you liked my lesson. And if you have any doubts, I am giving you my WhatsApp number. You can always text me there with your doubts. WhatsApp number will be given in the comments below. Thank you.